Hello everyone, welcome to the discussions of the past year questions. This video we shall discuss about the further mechanics, May-June 2022, paper 33. Let's take a look at the first questions. A uniform lamina OABC is a trapezium whose vertices can be represented by the coordinates in the xy plane. The coordinates of vertices are O, A, B, and C. Find the x-coordinate of the center of the mass of the lamina. So right here, this one is better that if we can draw the diagram, put the x-axis, y-axis, and we plot the O here, and 15, 0 for the point A. And for the point B is a 9, 4. So 9, 4 somewhere here. Then for the point C is 3, 4. So you can see that if you combine them together, this is a trapezium. So we can separate them into two triangles, one triangle, one rectangle, and one triangle. Okay, so now the situation is more clear over here. So in order to find the center of the mass, we will build the table. So we have the lamina. This one is a B, this one is a C. So maybe I call this one D. I call this point E. Okay, so if you take a look at the triangle number 1, it will be the triangle OBD. Okay, the triangle. Oops, I think I plot the point wrongly. This is supposed to be the C. This is supposed to be the B. Okay. Okay, so if we take a look at the triangle number 1 is a OCD. And we have the CBDE, the so-called rectangle, and the third triangle, ABE. And if you combine the three shapes together, you get a trapezium. So because they are same material, so we just need to consider the area only. No need to consider the mass. So the area for the first triangle, half times the base times the height, you get a 6. For the rectangle is the base times height, you get 6 times 4, 24. Same thing for the last triangle here. Base times height, half times base times height, you get 12. So the total together, you get 42. You're looking for the x-coordinate. So means you're looking for the bar x. So the bar x is measured from the y-axis. So the center of the mass from y-axis. Okay. So for the first triangle, actually, you just need to know that just take the coordinate for these three. Add together, divide by 3. So you just take the coordinate. That means you just take the coordinate 0, 0. The point D is a 3, 0. The point C is a 3, 4. So in order to get the x-axis, the center of mass of the x from the y-axis, just add 3 of them together, divide by 3. So you get 6 divided 3, you get a 2. Okay. So same thing over here. For the rectangle, it will be easier because rectangle, it will be in the middle. So 3 plus another, the distance here, this distance is 6. 6 divided 2 is 3. So 3 plus 3 is 6. Okay. Then for this, also same, just use a coordinate. The coordinate for the point B is 9, 4. The coordinate for the point E is the 9, 0. The coordinate for the point A is a 15, 0. So add 3 together, divide by 3. 9 plus 9 plus 25. Get 33. 33 divided by 3, you get 11. Okay, so this is what we have. So now to find the bar x, just find the moment about the y-axis. and you will get 6 times 2 plus 24 times 6 plus the 12 times 11 equal to the 42 multiplied by the bar x. So the bar x, you can just use your calculator. You will get 48 over 7. Or you can give the answer in the decimal form, 6.863 significant figure. Done. That is the answer for the question number 1. Okay. So now we move on to the question number 2. Okay, now we take a look at question number 2. A particle P of mass m is attached to one end of a light elastic string of natural length A, and the modulus of elasticity 4 over 3 mg. The other end of the string is attached to a fixed point O on a rough horizontal surface. The particle is at rest on the surface with the string at its natural length. The coefficient of frictions between B and the surface is 1 over 3. The particle is projected along the surface in the directions of OB with the speed half square root GA. Find the greatest extensions of the string during the subsequent motion. Okay, so at first you rest on the surface. Okay, so this is the O, this is the P. You are moving in these directions. You are looking for the greatest extension. So this extension is X. The natural length over here is A. Okay, so you start to move from here to here. Move from here to here only. Okay. And over here, your speed U is equal to the half of square root GA. And in order to reach to the greatest extension, your V must be a 0. Okay, your V must be a 0. So no height involved. So from the conservations of energy, okay. Now we have frictions. So to have frictions, we need to have mu R. Okay, maximum frictional force. So maybe we should consider the vertical forces first. For the vertical forces, you will have the normal contact force. R is equal to the mg. Your mass is m. So your frictional force Fr is equal to the mu R is equal to the 1 over 3 mg. Okay, so that is the first thing you need to highlight. Okay, then if you consider the conservations of energy, so you have KE loss. It become the EPE gain. Plus the work done by the resistant. Okay, work done by the resistant. So KE loss is half n of the U square minus the V square is equals to the EPE. It will be lambda over 2L of x2 square minus the x1 square plus the frictional force multiplied by the distance that you travel. Okay, so this is what you need to show. So for the m is still remain as m. The u is u. This is the u. So if you square it, you will get 1 over 4 GA. And at the end, you get 0 because you have used up all the KE. So no more KE in order to reach to the maximum extension. Okay, so your lambda, the question given lambda is a 4 over 3 mg over the 2a. Your extension is x. Originally, no extension. Then plus the frictional force, 1 over 3 mg by the distance that you travel is also the x. Okay, so if you simplify them, first of all, we can cancel the m. So this one is a 1 over 8 GA is equals to the 2 over 3 gx squared over a. Then plus the 1 over 3 gx. So the g also can cancel. And you multiply everyone by 24a. So you get 3a squared equals to the 16x squared plus the 8ax. So you will get 16x squared plus 8ax minus a 3a squared equal to 0. Let's see if we can factorize it or not. You will have 4x, 3a minus a. So you have a equal to the negative 3a over 4. X is equal to the negative 3a over 4. X is equal to the a over 4. The x cannot be negative, so we ignore the negative value. So therefore, your answer is x is equal to the 1 over 4a. That therefore, x is equal to the 1 over 4a. That is your greatest extension. Okay, so this will be the answer for this question number 2. Okay. So now we move on to the question number 3. Okay, now we take a look at question number 3. A particle is projected with a speed 25 meter per second at an angle theta above horizontal from the point O on the horizontal plane. Move freely under the gravity. After 2 seconds, the speed of P is 15 meter per second. Find the value of psi theta. Okay, so this is projectile motion. We will start from the horizontal displacement. X is equals to the 25 cos theta d. And the vertical displacement, y is equal to the 25 sine theta d minus the half g d squared. Okay, so they are talking about the speed when the time is 2 seconds. So we need to find the x dt and we need to find the y dt. So the x dt is 25 cos theta. The y dt is 25 sine theta minus the gt. So when d is equals to 2, your v is equals to 15. So for the v, the formula for v is the square root of the x dt squared plus the dy dt squared is equal to 15. Okay, so we are using this formula. And the x dt is not affected by t, so just write down this with the square. Dy dt is a 25 cos sine theta. I will use the g become 10, the t as a 2, so it's a 20 square. I bring the square root to the other side, become 15 square. So this one expands 625 cos square theta plus the 625 sine square theta minus the 1000 sine theta plus the 400 is equal to the 225. So we know that these two can become 625 because cos square plus sine square is a 1. So we get 625 minus the 1000 of sine theta plus the 400 is equal to the 225. At the end, the sine theta, just use your calculator. Need to write properly. So your sine theta, if you use the calculator to simplify it, you will get 405. Done for the part A. Okay. So you can foresee that the result for part A is actually telling you that you can use it to draw a small triangle here. You have a 4, you have a 5, then this one is a 3. We're going to use this information to solve the B, the range of the flight. Okay, so the range of the flight, just now, we know that for the y, vertical displacement, your y is equal to the 25 sine theta d minus a half gt square. So to find the range of the flight is the y equal to 0. So when the y is equal to 0, you will have 0 is equal to the 25, sine is the 4 over 5, d you do not know yet, and change the g become 10. So this is what you have. Okay, so just use the simplified. You will get this one as a 5d squared minus the 20d equal to 0. Take the 5d out, you have a d minus a 4 equal to 0, d equal to 4. Okay, so it takes 4 seconds. Okay, of course, d equal to 0, we ignore. Okay, so d equal to 4 seconds. So to find the range of the flight, height is range of the flight is x. So when t equal to 4, your x is a 25 cos theta d. The triangle that we have above here, the cos theta will be 3 over 5. So we put 3 over 5. The d is a 4. Press the calculator, you will get 60 meters. That will be the range of the flight. Okay, so now we move on to the question number 4. Okay, now we take a look at question number 4. One end of a light in extensible string of length A is attached to a fixed point O. A particle of mass M is attached to the other end of the string and is held with the string taut at the point A. At A, the string makes an angle theta with the upward vertical through O. The particle is projected perpendicular to the string downward in the downward directions from A with the speed u. It moves along a circular path in a vertical plane. When the string makes an angle alpha with a downward vertical through O, the speed of the particle is 2u. And the magnitude of the tension in the string is 10 times its magnitude at A. It is given that the U is square root of 2 over 3GA. Find in terms of M and G the magnitude of the tension in the string A. Okay, so first of all, we draw a diagram. So this is the point A. It makes an angle theta with the upward vertical. And you are moving with the U, where the U is equal to square root of 2 over 3GA. Then after that, you going down to the point B, and the speed over here is 2u. This makes an angle with the alpha with the downward vertical. So over here, what we can do is that we can straight away start from the conservations of energy. So you have the GPE loss is equal to the KE gain. So you have MGH equals to the half M of the 2u square minus a u square. Okay, so you cancel the M, then you will get 3u square is equal to the 2GH. So this is the H. Okay. So the U square is a 2 over 3GA. The H will be the A cos theta plus A cos alpha. Okay, so both of the GA can be cancelled. You can see that we have a cos theta plus cos alpha at the end. You cancel the GA and you get a 1. So you have a cos alpha is equal to 1 minus cos theta. That is my equation number 1. So we put this aside. Okay, now we want to consider the tension at A. At A, if you resolve the forces toward the center, so you will get dA. This is the dA. This one I call it dB. So dA plus the mg cos theta is equal to the mu square over the A. So you get a dA is equal to the m over A u square minus the mg cos theta. Take the mg out, you get 2 over 3 minus the cos theta. This one is equation number 2. Then consider the forces at B. If you resolve to the center, you will get dB minus the mg cos alpha is equal to the m of 2u square over the A. Get the dB equals to the m over A of 4u square plus the mg cos alpha. So you factorize the mg out, then you will get this one as 8 over 3 plus the cos alpha. That is your equation number 3. And we know that given the tension at B is 10 times the tension at A, so you will get mg 8 over 3 plus cos alpha is equal to the 10 times of the dA. Just make use of the equation number 2 and equation number 3, and you will get this. Cancel the mg, so you get 8 over 3 plus cos alpha is equal to the 20 over 3 minus the 10 cos theta. Okay. So over here, we can have 10 cos theta plus the cos alpha. Well, no need. We will make it like this. Cos alpha is equals to the 4 minus the 10 cos theta. That is your equation number 4. Equation 1 equal to equation number 4. You will have 1 minus the cos theta equal to the 4 minus the 10 cos theta. So you get 9 cos theta equals to 3. That will give you cos theta is equal to 1 over 3. But you're looking for dA, right? So from the equation number 2, dA is equals to 1 over 3 mg. Done. That will be the answer for the question number 1, number 4A. Okay, that's it. So now we move on to the B, find the value of cos alpha. So since we already have cos theta is equals to 1 over 3, so just now from the equation number 1, we have cos alpha is equals to the 1 minus the cos theta. So it will be 2 over 3, just like that. That will be the answer for the part B. That's it. That will be the answer for the question number 4B. Now, move on. We have question number 5. Now we take a look at question number 5. A particle P of mass 4 kg is moving in a horizontal straight line. At time t, the velocity of P is v meter per second and the displacement of P from a fixed point O on the line is x meter. The only force acting on P is resistive force, magnitude of given, t equal to 0, x equal to 0, and v equal to 4. So show by integrations that the v is equals to the following expressions. So we have horizontal force by Newton's second law, because you have only resistive force, so negative Fr, is equal to the MA. Your resistive force is given as the 4e power negative x plus 12 and e power negative x is equals to the m and then a. So your a will be equals to negative 1 over 4, 4e power negative x plus 12 and e power negative x. So you're looking for v in terms of x. So your a will be a v dv dx. Okay, just like that. So your v dv is equals to the negative. We can just expand everything. Okay, negative e power negative 2x minus the 3e power negative x. And then the whole thing here, you put bracket and then put the x. We put integration sign for both sides. So this one will be a v squared minus 2 equals to the half e power negative 2x plus the e power negative x plus the c. Just like that. Then given when the x is equal to 0, your v is equal to 4. So you have 16 over 2 is equals to half plus 3 plus c. Then your c is equals to 9 over 2. Okay, so put the c back into the equations here. V squared is equals to the half e power negative 2x plus the 3e power negative x plus 9 over 2. So you can see that the expression that they give you is v, no square. So we need to multiply everyone by 2 first. V squared is equal to e power negative 2x plus the 6e power negative x plus 9. So from here, we can actually factorize it like this. So your v is supposed to be e power negative x plus 3. By right, when you cancel the square, it's supposed to have positive, negative. But because the v that they give you is positive, v that they give you at the beginning is positive. Okay, so just keep it like this. Just mention that the v is positive. So your answer will be just like this. But not in the same form as they want, because they want in the form of fraction e power positive x. So we make it like this. Join it together. Shown. Okay, so that will be the answer for the question number 5A. Now we move on. Express x in terms of t. So from the part A, we change the v. From part A, we have this question. We have this answer. We just need to change the v become dx dt. So you have e power x over the 1 plus 3e power x dx equal to the dt. Put integration sign for both sides. So over here you will get 1 over 3 ln modulus of 1 plus 3e power x equals to the t plus c. Then when t equal to 0, x is equal to 0. T equal to 0, x is equal to 0. So from here, you can find the c. Now over here, maybe we don't put c, we put d. Okay, so you have 1 over 3 ln modulus 4 is equals to the d. So d is equal to the 1 over 3 ln 4. You can take away the modulus. So put the d back, you will get 1 over 3 ln 1 plus 3e power x
equals to the t plus 1 over 3 ln 4. So your t will equal to the 1 over 3 ln. Law of logarithms say that the minus of the ln, you can just put it together like this. But this is what we want. What we have is t in terms of x, they want x in terms of t. So we need to get rid of the e power 3t is equal to the modulus of 1 plus 3e power x over 4. So 1 plus 3e power x over 4 is either positive or negative e power 3t. But the negative, we will ignore the negative because it will not able to, if you accept negative, it will not able to fulfill the initial value. X equal to 0, t equal to 0. So the negative need to be ignored. But over here, the mark scheme didn't explain. Just straight away consider this as positive directly. So over here, you will get 3e power x is equals to the 4e power 3t minus 1. Okay, then x equal to 0. Then after that, your x will be equal to the ln of 4e power 3t minus 1 over 3. No need to put modulus anymore. Just put it like this. Okay, done. That will be the answer for the question number 5. Okay, so now we move on to the question number 6. Now we take a look at question number 6. AB and BC are two fixed smooth vertical barrier on a smooth horizontal surface. Okay, so this is the AB and BC. Okay, with the angle ABC 60 degree. A particle of mass m is moving with the speed u on the surface. The particle strikes AB at the angle theta. Okay, with AB, and it then strikes BC and rebound with the angle beta with BC. The coefficients of restitutions between the particle and each barrier is E, and tangent theta is 2. The KE of the particle after the first collision is 40% of its kinetic energy before the first collision. Okay, so for the question part A, we want to find the value of E. So for these questions, we will focus on the first collision. That means we will focus over here, first collision only. Okay, so for these first collisions, let me just draw the diagram. This is before. Theta, this is the U, and this is the after. So after I call this one V, the speed is a V, and the angle alpha, I call this one angle alpha. That means I will assume that this is the angle alpha. Okay, then from here, we will use the, we can use the conservations of linear momentum. Okay, the principles of the linear momentum. Okay, so the momentum is involving the vertical part. Vertical part. So if you involve the vertical part, principles of conservations of linear momentum. Okay, so we will have the E is equals to the V sine alpha over the U sine theta. Okay, so this is what we are having, and you will get V sine alpha is equals to the EU sine theta. But because the question giving you tangent theta is a 2, So you can build a small triangle here, 2, 1. This is a set 5. That means this one you can write this one as a 2 over set 5 EU. That will be your first equations. Now you consider the horizontal velocity. So you have the V cos alpha is equals to the U cos theta. Again, just use a small triangle. The cos theta is 1 over set 5 of the U. This will be your second equations. Okay. So now we make use of the last statement here. The KE after the first collision is 40% of its KE before the first collisions. Okay. Yeah. So we just say that the KE after is only the 40% of the KE before collision. Okay. So the formula for KE is a half m v square is equals to the 40% of the half m u square. Okay. So you can see that the half m and the half m can cancel off. So the v square, it will be you take the 2 square plus 1 square. Okay, so it will be 1 over set 5 u square plus the 2 over set 5 eu square is equals to the 2 over 5 of the u square. Okay, then all the u square can be cancelled. The u square can be cancelled. So you will get 1 over 5 plus 4 over 5 e square is equals to the 2 over 5. So you will get this e square is a 1 over 4. And then your e is a half because your e is positive. Okay, so therefore, done. This is the answer for the A. Okay, so you found the E. Now we move on to the part B. We want to find the angle of the beta. Okay, so to find the angle of beta, first of all, we need to know the angle. Angle of beta is involving in the second collision. Okay, so we need to know this angle first. To know this angle, we need to know the alpha. Okay, so we need to find the alpha. Okay, so we already know, we just make use of the equation 1 and equation 2 here. We already know the E. Just take the equation 1 divided by equation 2. Then you will get tangent alpha. Tangent alpha, if you divide it, you will get this as the 2 over 5 EU divided by the 1 over 5 of U. Cancel the U, cancel the 5, and the E is a half, so you get the tangent alpha is a 1. That means your alpha is a 45 degree. Okay, so alpha is 45 degree because the sum of the inner angle is interior angle of the triangle is 180. So this one is 75 degree. Okay, so now with the second collision, you have the V before and after. So before, the angle is 75. After, I call this one, the speed is a W, then this angle is beta. Okay. Okay, so this is what we need to do, the setup, before we find the answer for the angle beta. Okay, so what we can do now is, if you consider the horizontal, okay, so for this case, okay, so if you're going horizontal, that means the before and after is the same. That means the V cos 75 is equal to the W cos beta. Okay, So we just write down the W cos beta is equals to the V cos 75. Okay, then if you consider the vertical, it will be involving the principles of conservations of linear momentum. Then you will have the E is equals to the V sine beta divided by the, oh, sorry, not V, W sine beta over the V sine 75. Okay, so this is what we have. Then we already know the value of E. The E is a half. So you will have W sine beta is equals to the half V sine 75. Okay. Yeah, this is what we have. Then what we need to do now is I call this one number 3. I call this one number 4. I just take the number 4 divided by number 3. Then I will get tangent beta is equals to the half of the tangent 75. Just use your calculator and you can find the tangent beta. So let me press a calculator over here. Tangent 75 divide 2 arctangent, you get 61.8 degree. Done. That's it. That is the answer for the questions for number 6, part B. Okay, so now we move on to the question number 7. Okay, now we take a look at question number 7. A uniform cylinder with a rough surface of radius A is fixed with the axis horizontal fixed. Okay, that means it's not going to move, not going to rotate or anything. 2 identical rod AB and BC, each with a weight W and length 2A, are rigidly joined at B with the AB perpendicular to the BC. AB perpendicular to BC. Okay, so they are perpendicular. The rod rests on the cylinder in the vertical plane perpendicular to the axis of cylinder with AB at an angle theta to the horizontal. DE are midpoint of AB and BC. So this is a midpoint. Also, the points of contact of the rod with the cylinder, as seen in the diagram, the rods are about to slip in clockwise directions. It's about to slip in a clockwise direction. The coefficients of frictions between each rod and the cylinder is mu. And provided that the normal reactions between AB and the cylinder is R, and the normal reactions between BC and the cylinder is N. They want you to find the ratio of R to N in terms of mu. Okay, so this one, a lot of information over here. We need to put into this diagram. So let's make this diagram clearer. So first of all, we know that the weight of the rod is W and the center of the mass must be at the midpoint. This is the W and it's also the W. And you need to understand that this is the theta because of this is a theta, this is a 90 degree, this is a 90 degree minus a theta, therefore this is the theta. Okay, so you need to understand these situations. So this is the theta. This is a theta, then it will make this become a theta. And if this is a theta, then it will make this become 90 degree minus the theta. And it will make this become 90 degree minus a theta. And therefore, this is a theta. Okay, so let me clear this one out. So this is the angle that is important for us. Okay, then there's a normal contact force at E. This one is they call N. And this one, the normal contact force over here is R. And since they're about to slip in the clockwise direction, so the frictional force will go this way, opposite. This is the Fn. This is the Fr. Okay, so since they're about to slip, that means they are in a limiting equilibrium. So first of all, we need to understand that the Fr is equal to the mu R and the Fn is equal to the mu N. First thing, we need to understand that Fr is equal to the mu R and Fn is equal to the mu N. Okay, then after that, we try to resolve forces. We try to resolve the forces along the rod AB. Okay, we try to resolve the forces along this way. So if you try to resolve the forces parallel to the AB, okay, we try to resolve the forces parallel to AB. So if you try to resolve forces parallel to AB, then you will get, you will involve this, and these two. This one not involved, this one not involved. So you will have N is equals to the W sine theta plus W sine theta plus FR. Okay, so you will get N is equals to the FR plus the W sine theta plus the W sine theta. Therefore, you will have a mu R plus the 2W sine theta. That is the N. Okay. Then if you resolve the forces parallel to the BC. Now we want to, okay, let me clear this one up. Now I want to resolve the forces parallel to the BC, or we can say perpendicular to AB. We want to resolve the forces along this way, parallel to the BC. Okay, so it's only involving Fn, R, W, and W. This is not involved. This is not involved. Okay, so you will have Fn plus R is equal to the W cos theta parallel to the BC. You will have Fn plus R is equal to the W cos theta plus the W cos theta. So you will get mu N plus R is equals to the 2W cos theta. Okay, this is what we have. Then seems like we still cannot get the answer yet because we are having data here which is unknown. We're not able to do anything with the data at the moment. So what you need to do is we need to use one more tools. One more information over here is we take the moment. So you can take the moment at anywhere that you like. You can take the moment at D. You can take the moment at E. You can also take the moment at the center. You can also take the moment at B. So over here, I will take the moment at the center. Okay, take the moment at the center. Okay, so I want to find the moment about the center. So if you take the moment about the center of the cylinder, then you can see that you will have Fn multiply A plus Fr multiply A. You will get Fn times A plus the Fr times A. And then the moment over here, if you extend the length here, it will be A sine theta, W A sine theta plus the W A sine theta equals to the distance here, the perpendicular distance, W A sine theta as well. Okay, no, there is a W A, this is the theta. It's a W A cos theta. Okay, so you can cancel all the A. If you cancel all the A, you get mu N plus the mu R is equals to the W of cos theta minus the sine theta. Okay, so over here you can see that we can get rid of the theta here by try to combine them together. So now we try to make use of the information that we have found earlier. So over here, let me make this as the N minus the mu R is equal to the 2W sine theta. Okay, so I take this as the number 1. I take this as a number 2. And I take this as a number 3. Okay, so if I take the number 2 minus the number 1, 2 minus 1, I will get 2 minus 1, mu n plus r minus the n plus the mu r is equals to the 2w of the cos theta minus the sine theta. Then I will get the, from here, I will get mu n plus r minus the n plus mu r over 2 is equal to the w of cos theta minus the sine theta. So I call this one equation number 4, and you can see that the equation number 4, this part and this part are the same. Okay, so since they are the same, we can just let that number 3 equal to the number 4. Then you will get the mu n plus the mu is equal to the mu n plus the r minus the n plus the mu r over the 2. Okay, so you get 2 mu n plus the 2 mu r is equal to the mu n plus r minus the n plus the mu r. Okay, then at the end, you will get mu r minus r is equals to the mu r minus r is equals to the okay, we do like this. We'll get the mu n plus n is equals to the r minus the mu r. So at the end, r divided n is equals to the r divided n is equal to the mu plus 1 over the 1 minus mu. Therefore, r to n is 1 plus mu to 1 minus mu. Done. That is the answer for the questions number 7A. A bit long. Okay. So I hope it doesn't affect you from understanding. Now, continue with the part B. They are telling you that the mu is equals to 1 over 3. So mu is 1 over 3. Now we straight away just use it as information, just change the mu become 1 over 3. Then you get 4 over 3 divided by 2 over 3. Then you will, from here, you will get the relationship that R is equal to the 2n. You will get R is equal to the 2n. Okay, so from here, R equal to 2n, just go back to the r is equal to the 2n. So from the equation number 1, we want to find tangent theta, right? From the equation number 1, r is equal to the 2n, mu is equal to 1 over 3. So n minus a 1 over 3 2n is equal to the 2w sine theta. And you will get the w sine theta is equals to the 1 over 6 n. Okay, then from the number 2, you can see that equation number 2, you will have equation number 2 is over here. Mu n plus r is equals to the 2w cos theta. Mu n plus r is equal to the 2w cos theta. Then you get w cos theta is equals to the 7 over 6. Okay, so therefore tangent theta is 1 over 6n divided by 7 over 6n. Then you get this as 1 over 7. Just like that, that will be the answer for the question number B. And that will be the last questions over here. So I will see you in the next video. Bye-bye.